All right, good day, everybody. This is Jason Strait with the Cloud Pass Virtual Group. Our session today is Don't Cross the Streams, a closer look at Azure Stream Analytics. And our presenter is Johan Brattås. I know I screwed up that a little bit, but best I can do at the moment. To get things started here today, though, I'm going to do a couple announcements real quick, and then I'll pass things over to Johan. So the sponsor for the Cloud Pass Virtual Group is Quest Spotlight Cloud. Spotlight Cloud is the first Azure-hosted database performance monitoring solution focused on SQL Server customers, leveraging the scalability, performance, and built-in security of Microsoft Azure Cosmos DB. Spotlight combines the best of the cloud with Quest's engineering insights from years of building database performance management tools. If you are interested in presenting, we do have lots of open spots because we're doing as many Tuesdays and Thursdays as I can find presenters for. So we've got sessions all the way through, I think, the middle of August, but there's plenty of months after that, so we're looking for more speakers. If you are interested in speaking, you can just send an email to cloud@pass.org. Alternatively, you can go out to the Pass Cloud website and just click on the link for the call for speakers. Go through that link and get signed up, and we'll get you scheduled. This virtual group is part of a number of virtual groups that cover a bunch of different areas, be they language like Global Chinese, Global Hebrew, or different job roles such as database administration. There's lots of learning that's available from the PASS organization through these virtual groups. With that, that's all of the announcements that I have for today. So I'm going to hand things over to Johan for our presentation today, Don't Cross the Streams, a closer look at Azure Stream Analytics.
Yes, thank you. I hope my screen will be loading up in just a few seconds.
Yep, coming through looks great.
Perfect. All right. Let's see if I can get this presentation going. Good. Yes, my name is Johan Brattås. Slightly hard to pronounce Norwegian names. I'm a managing consultant at Capgemini in Norway. You might find me on LinkedIn or find me under the Twitter handle Intolerance, not because I'm an intolerant bastard, but because I have some food intolerances I sometimes speak about. I'm also organizing SQL Saturday in Oslo. I do different kinds of volunteering stuff for PASS as well, and I do teach people how to make celiac or gluten-free food. So, agenda for today is working with unbounded data, Azure Event Hubs, Azure Stream Analytics, both as an architecture and role, but also the syntax of the language. And we'll be taking some peek at temporal windows and timestamps, and we will, if time permits, see a little bit of how to troubleshoot different scenarios there. So, what is unbounded data? Unbounded data is the data that is coming in non-stop. You can have pauses, so it comes in every minute or so, every 5 minutes, but still it's coming in steady stream. One way to look at it is like this picture, which is a bridge, which was the only connection between my home island and the city of Bergen when I lived there. And it's not generally that easy to sum up by the end of the day how many cars are passing over the bridge at any given time. So several ways of dealing with data. Of course, you can start counting the cars that are passing by stopping them, gathering them for, let's say, 24 hours, and then count them, which is not very popular among the drivers, I'll tell you that. Of course, you can also take a snapshot of a certain minute of the day. So let's say you count the cars crossing the bridge at 12 o'clock in the morning, and that will give you a certain idea if you then add that up during the day, but still you'll be missing variations in data stream like rush hour and so on. So normally when we're dealing with streams, we are dealing with temporal windows and we'll be sampling data throughout the day or doing aggregations on those data continuously using temporal windows. And this way you can have control over what passes through at any given moment. You can even do machine learning on these things. And that means that windowing is a very central function to working with unbounded data. But in a cloud architecture, you do have certain different objects that you need to look at. And one of them is the Azure Event Hub. And what role do the event hubs play? Well, the event hubs are the ingestion points to your cloud. And there are two different hubs that we are looking at when we're dealing with the Stream Analytics. You have the event hub itself, and you have an IoT hub. And these, as I said, they are the ingestion points. They receive data from your applications, from your devices, and then they will store them for a certain amount of time as a sort of a commit queue, really. So then you have consumers on the other end that are grabbing that data and doing something with them, either that just storing them into a blob or doing aggregations, analyzing things, or dumping it into data lakes or databases afterwards. The Azure Event Hub is receiving these events either through HTTP or AMQP protocols. And when you're creating an event hub, you create a certain amount of partitions. And the events will be distributed into these partitions, normally in a round-robin fashion. But you can do partitioning by, for instance, an event ID or something else if you want to, and control into which partition each kind of event should flow. And again, these partitions are commit queues. So the event hub stores your messages as they come in, and then presents them down the stream to your consumers. And your consumers have to belong to a consumer group to be able to access these partitions. And when you're creating an event hub, you can create as many consumer groups that you want. Best practice will be to create as many consumer groups as you are having consumers. And the reason for this is that in any consumer group, it's just one consumer within that group at any given time that can access a given partition. So to avoid having your consumers wait in line to get hold of the events, it's a lot easier to have one consumer per consumer group. The Azure IoT Hub is slightly different. It supports a lot more protocols, or not a lot more, sorry, it supports one more type of protocol. So AMQP, MQTT, and HTTPS. And it is meant to deal with device data, and it's meant to talk to the devices. So it has device to cloud ingestion, and it can also send messages or commands from the cloud to your device. And it has an added degree of security in that it has a per device authentication. If you have devices that are not AMQP, MQTT, or HTTPS supported, you can put in an IoT protocol gateway between the cloud and your devices that can translate for you. There are suggestions for these in GitHub that Microsoft provides you. If you have low power devices, or you have devices that are non-IP aware, so you can talk to them over COM cable, for instance, you can put a field gateway. Again, there are the sample source that you can download from GitHub. And these field gateways connect to and talk to your devices and translate the messages and send them off to the IoT Hub for you. So the IoT Hub has a bidirectional communication, and it's pretty scalable, but of course the more devices you connect, the more expensive the IoT Hub will become. It works with the most standard industry protocols and platforms, and it authenticates per device for security-enhanced IoT solutions. And over the last few years, Microsoft has added a lot of nifty features to administrate these devices. Earlier on, it was a very manual process to register and control your devices. And it's based on Azure Event Hub's technology, which again is a service bus technology. So supports a variety of platforms and protocols and languages. And as I mentioned, the difference between the Event Hub and the IoT Hub is that only the IoT Hub supports two-way communication. It's only one that supports per-device security. But Event Hub support direct backup of the feed, so you can dump your data directly into a blob store in an Avro file format. I have heard some rumors that they're planning on increasing that, but I'm not sure if that's been publicly available yet. But of course, the price for the Event Hub is generally cheaper than the IoT Hub until you start doing backup. I think then it triples in price. And of course, the IoT Hub supports one more protocol than the Event Hub. The Event Hubs are based on Service Bus technology. If I go into, let's see, you can take this. Okay, a bit of lag in the network here. And I connect to this. Sorry, it was the wrong one. And as you can see now, I have two event hubs connected to this namespace, which is quite confusing when you're starting dealing with or you're setting up your first event hub. Is that you select the new event hub from the Azure portal, but the first thing that you will create is a namespace. They've done some changes now, so it's a bit easier to see the difference. But first you connect and create your namespace, event hub namespace, and then afterwards you create your event hubs underneath that. And then underneath the event hub namespace and the events, you have the consumer groups, and in this case you have 4 different ones. This is a test or staging event hub, and you can drill down. This is also something that's available from GitHub. So you can, this Service Bus Explorer can be available, and you can create a partition listener and listen to events coming in. So, yeah. So as you can see, there are several events popping in at the moment. And as well, when you're dealing with IoT, you also have something called the Device Explorer, which is also source code that you can download from GitHub, where you can connect to, the IoT Hub by access key. And you will see here all the devices that are connected to it. And you can monitor, as said, certain sensor to see if there's any data coming in. Right now, these sensors are shut down. These are sensors that are running during wintertime only on an airport in Norway. But if they had been operating in wintertime conditions, you would have seen the data coming in here. So there are tools to connect to and listen to your devices. I forgot to mention that the Service Bus, the Event Hub Also, the Event Hub do not have any per device security, but it just does have a shared access key. And this is slightly less secure, but you can have the option of both using access keys that only allows for reading or only allows for listening. And normally you give out to your event producers only the key to write, and your event consumers only the ability to listen. And in addition to this, we have something called Iot Edge. And Iot Edge is a container that is running via Kubernetes in your own on any machine you own, and you commission these Iot Edge devices in your Iot Hub and you as Iot Edge devices. And these Iot Edge devices contain both an Iot Hub, so you can connect to your on-premises devices, and it also has Azure Stream Analytics engine built into it with a limited subset of features. But this is specific for scenarios where you, for instance, on ships or oil platforms or places where you have slightly costly connection features, or when you know that you are offline for any given amount of time, so you want to aggregate up the events coming in and then send them off when you are able to ship the data into the cloud at a later stage. Sorry, my throat got a bit sore here. As I said, it's a bit limited, but it's a very nifty feature for these certain scenarios, and it is also available for the Azure stack if you do want to have a more powerful on-premises solution. So, Stream Analytics is two things, and in this context is the real-time event processing engine within Azure. It is serverless, it is easily configurable, and it consists of three things. Of course, this is also a container. It has an input, it has a processor or a query, and it has an output. And you have four supported input types. You have the Event Hub, Iot Hub, Blob Store, and Azure SQL DB. However, you have also two different kinds of inputs. You have event input and you have lookup data input. And Azure SQL DB is only available as a lookup source, whereas both Event Hub, Iot Hub, and Blob Store can function as input stores. Normally, though, you will probably even receive your events via either Event Hub or Iot Hub, and you use Blob Store and Azure SQL DB for your lookup data, so you can enrich the data stream coming in, for instance, by giving devices more user-friendly, human-readable names, for instance. You have ever-increasing number of supported outputs or sinks. Again, you can send off to Event Hub, SQL DB, Blob Store, table storage, service bus, queue, and topic. Cosmos DB, PowerBI, Data Lake Store, however, just generation 1 at the moment. Hopefully generation 2 will come along soon. And you can send off to an Azure function. However, you cannot do more than 7 simultaneous inputs, outputs. So if you have 4 inputs, you can only have 3 outputs. And that is, that will fail the job if you're trying to run anything else. So it's pretty easy to set things up and running. Okay, this wasn't anything prepared. Let's go back and look at what's something that is in production. So in this case, I have two different input streams, and I have 7 outputs defined, but as long as only certain of them are active, it doesn't fail. It's as long as I go into the query and I start connecting to all the different outputs and inputs I have, that's when the job will fail. In this case, I only have event stream active, and I have one of the blob story is not active in this job, so this is why it runs fine. The Stream Analytics language is a subset of T-SQL, which is good because it means that it's easy to start using. However, if you're used to using T-SQL, you'll start hitting limitations quickly. So why does this fail? I mean, it's valid SQL, but because it's Stream Analytics is a subset, it's not supported within Stream Analytics. So you'll have to go back and forth to the reference library in docs.microsoft.com quite frequently to validate your codes and see why you hit the limitations that you do. The major difference in the language, of course, is the timestamps and the different temporal windows that you are running on. And it's basic syntax, so select from, join, where, having, group by, union, etc. You only have a few data types, so begin, float, envarchar, max, datetime, record, and array. And I guess most of you know that it's not very easy to index on character types or data types of type envarchar, max, and begint. However, if you are pushing data into a SQL table and you know the schema and data of your events coming in, Stream Analytics really does not care about the data types of the output. So you can have a table based with envarchar 100 or varchar 50, and not as long as you don't define which data type your schema is in or your events are coming in, the job will run until you have an overflow or a truncation. Then it will fail. But as long as you know the events you have coming in, and you know that it will not go more than varchar 100, that is fine. Stream Analytics doesn't care about that. Of course, since it's an analytics language, you have various aggregates, and you can do analytics on the stream. So again, you're looking for events of is first, or you want to introduce a lag, or you're looking for the last event. You have support for that, and you have some simple cast and get type conversions. And of course, various date time operators as well. And you've also got added geospatial data. So you can do your traditional create line, create point, polygons, distance, overlaps, intersects within. And these are very handy. In one project I've done, we've been getting data from trucks spraying out de-icing fluid on runways at airport in real time, and we mapped that onto a GIS map in PowerBI, so an ArcGIS add-on in PowerBI. And then the operation room can monitor in real time when the trucks are out spraying fluids on the runway. So both where they are and where they've been and the amount of fluid they put on. Hopefully we'll later on be able to put in some geo mapping as well, so you do geofencing, so you can have as long as they are within this area, you shouldn't see anything because that's military space or it's the garage, these kind of things. So it's very handy to have these kinds of features within Stream Analytics. You can also have some functions. You have user-defined functions in JavaScript in Stream Analytics in Azure, whereas user-defined functions in the Edge, it says also supports here, but it only supports C# user-defined functions. And you have a user-defined function for machine learning, but that is also only on the portal or in Azure. It's not supported on the Edge. But this means that you can call machine learning models from within your stream and do anomaly detection and fraud detection, these kind of things over stream data. When you are developing on Stream Analytics, you have Visual Studio with an add-on for Stream Analytics, which is nice. It's a familiar tool. It makes it easier for you to put things into source control, but it lacks certain features. For instance, you can't add PowerBI as an output. Well, you can add PowerBI as an output, but when you deploy that to Azure, it will fail. So it might be easier to add the PowerBI output later on. The web interface that I just showed you a bit earlier in Portal is the one that we started using, and it's easy to use. It supports all the functionality that you need, but it lacks source control. Hopefully they will make us able to export the ARM template afterwards, so you can at least add that to source control later on. Also in preview right now, you can, if you are a fan of code, you can download an add-on in open preview for Stream Analytics and Data Lake tools, so you can start using your favorite cross-OS editor code to develop on Stream Analytics as well. I started using Stream Analytics in the portal, both because it was easy and available, and when the Stream Analytics add-on to Visual Studio came out, it was so full of bugs. So I got frustrated very quickly because it crashed all the time, and I just went back to the portal. But these days, it is quite nifty. It's, let's see if I forgot to add zoom it, sorry. So as in the portal, I have the ability to put in different inputs and outputs. I can also add local inputs, which means that I can download a sample from my Event Hub and use that sample to run against offline. This spring they added the ability, I think it was a March feature, they added the ability to use your cloud input as and then without really bothering the flow, you could test on the live data. And it's very easy to test this. You double click on the output and you configure. You can pull, when you're logged in, you can pull from the different source, sorry, boy, I haven't been logged in for a while, it seems. You can add from the different event hubs that you have, and then it will just populate it easily afterwards. And of course now, because the demo goals failed, I think I need to see if I can log on again. Sorry about that. And we're good to go. So now it's connected. It's easily populating the different things I need. And then I can do pick whatever I want and the event I need, and then further on and populate everything. But this time I'll just show you, I can run this locally and I have output to local. Hopefully that will be able to be able to output somewhere else later on. And it starts up the instance and runs through the file that I have defined as a local input. It takes a minute or two to spin up and then to start reading into the files. So as you can see, it's run through the files and spun out the different parts of the JSON file into the columns that I wanted to. And let's see, one of the pain points developing on IoT devices is that sometimes the device itself is not really well documented. So you will have to start guessing what the different values are, and you have to really get into and learn the schema of and the type of data that you're looking for to convert that into something sensible. In this case, the different errors that they are sending weren't well documented. Some of them I've just had to guess what are. And then you have to start browsing through and filtering out things. There is, as you can see, again, you have to just listen and see what you can find and then try to interpret those and translate that into text for the, this is going straightly into a PowerBI report. So in this case, you have to start looking at values that might be 2 or 3 integers and then translate from that. If you are doing this in the portal, it's basically the same. But since you in the portal you can't listen live to your data stream, you have to sample the data because this is running. You can't see it properly, but you can either sample data from input or you can upload sample data from file. And you can run your sample, you can run your development on that to check if you got the right, if you understood the schema correctly. And one major pain point I've seen is that for JSON that is has several nested arrays within their objects, it might be a pain to wrap them out properly. So you have to start using outer apply to get the elements from the nested arrays and put those into your code afterwards. So you have a nested array being outer applied here again. But it's quite easy to test it. It's quite easy to develop on it. Apart from when you are starting and stopping the instances. It takes a bit of time to wait to get things running to really see how things progress. So the first of these samples that I showed you, we're pushing data straightly into Power BI Live dashboard. The dashboard itself is made for wintertime, so it the live dashboard isn't really interesting at the moment, but this is a screenshot of how it looks when it's operating. And it's made for, again, these de-icing fluids trucks when they should be sent out into onto the runway to put glycol to avoid to increase the friction so their craft don't crash. Previously, they had to send somebody out of the control room and down to the lowest point of the airport to check if it had frozen there, because if it frozen there, it would be about 10 minutes until the runway started freezing. So this, of course, is a huge time saver for them. Yeah, I'm not going to show you this case sample video because it's in Norwegian, so I'll just skip that. So back to Stream Analytics. Tumbling Windows are one of the different windowing types that you can get when you are dealing with the aggregations within your stream. And the syntax is simple. It's select something into something from the input, and you group by an ID or event ID, and the syntax for the tumbling window is then duration, hour, and 1. And that specifies that duration is hour and the number of hours that the duration is set for. You also have another feature that you can add, which is offset by either millisecond, second, hour, and -1 here sets that the next tumbling window will start 1 second or 1 millisecond before the last one ends. So tumbling window is the easiest window to use. It goes, listens along your stream, and it just starts off when the last one finishes unless you have offsets defined. But it will just continue listening to your stream and grouping even though there are no events within that window. Your hopping window has the same kind of duration from minutes or hours or seconds or days up to a week, I think. Then you have the duration of the value of the duration, so 10 minutes, and then it has a compulsory offset. So when you say 5 here, it says 5 minutes before the last hopping window ends, the next hopping window will start. Which means again that you will get regular intervals. You might have windows where there are no events, but you will also have events that are coming into several or more than one temporal window, which means that you will have some duplicate events that you have to consider when you're looking at the data afterwards. Then you have your sliding window. And the sliding window has, again, the duration type, minutes, hour, day, week, the number of duration that you have, but it will run until it's run from an event occurs until the duration ends. So if you have an event starting, it will run for 10 minutes and it will register all the events that are coming into that window, report them, and then shut down after 10 minutes. However, if there are more events coming in, that will also trigger a new window. However, it doesn't, if there are no more events, it will wait until the next event comes in. So if you have events coming in a bit irregularly, it will give you time from where there's no windows happening. But of course, when there are more events coming into one window, you might get duplicates kicking in because it kicks off another sliding window. Last window is the session window, and that says, again, duration, amounts of duration, and then it has an extensibility. So it says, okay, this window should run for 5 minutes. However, if there are events coming in at the end of the 5-minute window, you can extend this window by 10 minutes. So a window might last for 15 minutes. And this also triggers when there are events coming in. So it's a feature that can be good if you have even the events coming in very irregularly. But again, it will trigger off on new events. So you again have to consider the duplicates that you can potentially get from this. So temporal windows are the hardest part of Stream Analytics to get. But for most cases, the tumbling window is very easy to set up and it's quite easy to grasp. And personally, I haven't met any scenarios where I haven't had to use, where I've had to use anything else but tumbling windows. So it's, but that might change when you're dealing with this in a live scenario. Rather in scenarios different from what I've been seeing so far. This other different feature from in Stream Analytics is a timestamp. And this is because an event can have several different timestamps. You have, for instance, if you're dealing with point of sales, you might have a timestamp when the object was picked from the shelves. You might have one when it's been scanned by the cashier, another when it's been when it exited the store. Then you have another one when the event has been put into the Event Hub, a new one when it was received in Stream Analytics. And this means that you have several different timestamps, and you can choose which one you want to group by. And this is when you use the timestamp by, and you select the name of the timestamp that you want to use. So it's quite easy to understand this, and it's easy to use. As I said, general availability now, you have live data testing in Visual Studio. There is also quite nice if you're dealing with high volume of data coming into SQL Server. You have a high throughput option in your SQL DB output. You can also now blob output partitioning by custom datetime formats. You can have your user-defined custom repartition counts. And the query extensibility, so you can create more advanced Stream Analytics jobs on your Azure Iot Edge devices. They did have some new features announced on build as well, but I haven't been able to put those into my session yet. Then anomaly detection on Iot Edge is not publicly available yet. It's still within private preview, and I'm not sure when that will be released. And one thing that I'm looking forward to right now, they have managed identities for Azure resources. So if you are putting data into Azure Data Lake Storage Generation 1, previously you had to re-authenticate every 3 months. Now you can use mentioned identities, which means that you don't have to re-authenticate with your developer user account every 3 months, which is very helpful, specifically have consultants developing for you, and they leave, and then somebody else has to remember to take over that account. You still have to do that with PowerBI, but hopefully they will be releasing some fixes to that sometime this year. So when you are dealing with operation of when you're putting things into production, there are some things to consider. And one of these is your scaling. because your SQL, your your Stream Analytics job is running on a container with a set amount of CPU and memory. And those are defined as the black box streaming units, which you can access through the Scale app or the menu in your device. And then you scale from, per default, it's set as 3. But normally people drag it down to 1. The challenge with that is when you are running things and your Stream Analytics jobs run out of memory, it does not fail as such. It just takes a little while to realize it's out of memory, and then it stops processing or outputting anything at all. But there's no failure notification. There's nothing really telling you that things have gone wrong. So you need to be careful and monitor your instances, because I mean, Stream Analytics isn't cheap. It's not expensive either, but it's not cheap. So you want to keep your cost as low as possible, and that means you need to put your streaming units as low as possible. However, you might hit into certain unprecedented peaks, which then fails your output. I had one of these instances a few months ago where we had reduced all the Stream Analytics jobs down to 1 streaming unit for cost savings. And suddenly one of my jobs started failing, or it just stopped outputting things. And it turned out that every morning at 9 o'clock there was an unprecedented burst of events coming in that we hadn't seen in tests, and we hadn't seen it in production earlier either, because they had just added new event producer into into the Azure Event Hub without letting us know. So after scaling that back up to 3 streaming units, it has been running non-stop without any problem. But it's important to be aware of the limitations of the Stream Analytics streaming units and memory of this container, and that it doesn't really tell you anything at all. It just kind of stops outputting anything at all without sending any warnings. With the changes that have been coming into the Stream Analytics language, you also have introduced Comparability Levels. Again, there's a specific menu for this in your portal, where you can define either 1 or 1.1. They haven't had any more levels on the Stream Analytics jobs for now, but that might come in later on. But for your old jobs, you can, per default, it's set as 1.0, and then you can increase it to 1.1 if there are any new features that you want to add. Specifically, this is related to the windowing functions. Last one, the session window, is so new that it has to be running on 1.1 to run properly. And you will from time to time see that you get problems formatting documents, or you can see that you have this orange triangle will warn you if there's any issues. One annoying part is that if you put a lot of different event producers sending the events into the same event hub, so you have lots of different schemas coming in, you might get warnings on your event hub, on your Stream Analytics job, that there is suboptimal performance going on. But at the same time, it really doesn't affect that job itself. The job just warns you because something is going on one of the other different event types that are running through the event hub. And you can, of course, then you can turn on diagnostics and collect data to your log analytics system and look at these data going in afterwards. So I have been talking very fast today, so I'm finished a bit before time. Do we have any questions?
Yes, we've got a couple of questions here. Let me just start at the top. Is window tumbling, hopping, sliding something we can use to limit the amount of data that goes into Power BI Sync?
Yes. You typically want to aggregate to the granularity that your user wants to see in the Power BI report. For instance, this dashboard I showed you, they wanted to have data every 5 minutes. So then I was running a tumbling window on a 5-minute aggregation.
Okay. And is it possible to test Azure Function Sync using Visual Studio?
I haven't tried that, so I'm not sure. But since you can only output to local, I would think it's not properly possible, no. But if you set it up and test the Stream Analytics part and then put that into the portal and try from there, that should be an option.
Okay, great. And the last piece is just a comment that they're looking into email alerts using Stream Analytics. That was the point behind their questions. So great. We don't have any other questions for today. Johan, thanks for presenting here today. This has been a great topic. And thank you, everyone, for attending. At this point, I'm going to close things out and say just thank you, everyone, for being here again.
Thank you, everyone.